Hi, I want to add my 2 cents on the debate about the solar eclipse of August 21st, 2017. Flat earthers began imagining problems with the eclipse. The first one I saw was from Political Hillbilly and Antonio Subarats. I apologize if I mispronounced that name. They said they were sure that on the heliocentric model, the eclipse shadow should travel from east to west, not west to east as forecasted.
There's the shadow of the moon, and the Earth is moving faster than the shadow of the moon, because the Earth spins around its axis faster, in terms of time, not in terms of kilometers per hour. In terms of time, the Earth turns around its axis once every 24 hours. The Moon orbits Earth's axis once every 28 days.
The crux of this argument is the true belief that in order for the shadow of the moon to go from west to east, the shadow would have to outrun the Earth's eastward spin. But they mix that with a false belief that this would be impossible given that the Earth is said to rotate once per day around its axis, whereas the moon orbits once around the Earth's axis in 28 days. Sly Sparkane created a very excellent animation debunking their criticism. It's bulletproof and easy to understand. We'll watch a little segment here. These are various moons. This would be the distance to the real moon, and these are closer ones to make the point. But these are going to be rotating around. It takes them 28 days to get around for the Earth's one way.
East to west. East to west. East to west. Not west to east. East to west. East to west. East to west. Not.
Anyway, I recommend you watch the whole video, and it shows that when modeled correctly to scale, the heliocentric model doesn't have a problem with the eclipse direction.
So 0.03% of a 360-degree alleged orbit is not that much of an angular change. Now, I'm not saying that this means the Earth is a spinning sphere or any of that. I'm just saying that it's hypothetically possible to have the heliocentric layout where the moon's shadow, or the totality of an eclipse, travels from west to east.
In fact, I thought the solar eclipse worked before this week and 100% disbelieved the globe. The problem now, though, is that we have many incorrect videos out there, many mirrored, and tons of comments that make Flat Earth look bad. This is kind of upsetting because there are so many issues with the globe model. The last thing we want to do is hang our hats on the things that the globe does have right.
So both Jaron and John, the Morgile, are basically telling their subscribers, look, this is not the thing to focus on because it works fine. But irony abounds. They get to see firsthand that some of their community can't or won't understand legitimate argument, such as this. HTF, can a globe model of the eclipse be correct? Go wash your mouth out with soap. The eclipse model NASA is showing shows the Earth rotating in the wrong direction. This is referring to something else that the Potter's Clay said, which is silly. The rotation direction is shown by the night terminator line, and if you look at it, it is rotating correctly. And their loyalty gets questioned. Ha 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 ha. True colors coming out, Baylor. And then Jaren is having a bromance with Wolfie. Wolfie is a globe proponent who has some videos. And Jaren has had the audacity to think that some of what Wolfie said is not nonsense. And oh my gosh, what a bitter pill it must be to know that those flat earthers sniping at them aren't really critically thinking at all, but being loyal to a paradigm and putting on blinders. Hey, that's what globe-tards are supposed to do. Or perhaps an even worse realization or suspicion hits Jaren that perhaps some of his subscribers literally do not have the intelligence capacity to understand what is being said. In spite of the work done on the west-east eclipse shadow, even verified by some big-name flat earthers, a YouTuber going by the Potter's Clay has resurrected this error. He also snipes at various mainstream eclipse models and animations. All he shows are various problems with himself, rather than the animations. He shows that he doesn't really understand such things as scale and perspective. He shows that he gets confused over camera position. He shows that he can't understand the compromises which are made in order to make an effective demonstration that fits on your screen. For refuting the west to east problem, I can't do better than to just refer you back to Sly's video.
But explain this. This is supposedly an image from space of an eclipse over Mexico. And if you look at a map, you can see that's 50 or maybe 60 miles across. Hard to say, but it's not a quarter the size of the Earth. But could the moon cast a shadow smaller than itself? Look at this illustration. If the ball is right up against the surface, the shadow is the exact same size. And if it gets farther away, the edges might become blurry and the shadow can actually be bigger than the object, but it can't be smaller. Don't you scratch your head for a minute and go, how is that possible? The shadow is the same size as the object in all scientific demonstrations. Now, when they show you one of their baloney illustrations and say, no, this is the magic. Look, the sun is so big it encompasses everything around it and the light just kind of shoots itself up underneath the moon and makes a spot smaller than the moon. And they tried to replicate what they claim happens with this model. On the right you have the Earth, then you have the moon, then they inserted a light diffuser, and that light diffuser is between the light source and the moon. So you can see that somehow the shadow is manipulated in such a way that it looks like it's a little bit smaller in the middle, a little hazy around the edge. And this is what they tell us that eclipses do. But in the real world, where's the diffuser?
I think it's funny when the Potter's Clay says that in all scientific demonstrations, the shadow of an object is the same size or bigger than the object casting it. But then he shows this very picture in his video. I mean, what is he thinking? What is this if not a scientific demonstration? And what is it doing but showing that this shadow is smaller? He says the shadow has been manipulated by a diffuser, and that's not fair play. But his objection is baseless. This is a lens, and all it does is magnify the light source so it's bigger than the moon, like the sun is. It's perfectly fair and perfectly contradicts what he has just said with such conviction before. If the light is bigger than the object casting the shadow, then the shadow definitely can be smaller. The light angles around the edges and makes the shadow smaller. This looks very much like the diagram that was shown just before. So there you have it. In the real world, a large light source casting a smaller shadow. That should be case closed. But let's watch the potter's clay resist the true explanation.
Some troll left a comment on one of my videos. It was the solar eclipse video, and basically what they were talking about was how simple it is to see the situation if I had a brain, and that would be to just draw a line from the sun across the moon, and then from the moon, on the other side also, and then I would see that, well, clearly the shadow cast by the moon would be smaller than the moon. So I started looking at that, and let me show you what it looked like to me. Tell me what you think. So look at what he said to draw that would make it so obvious. We have lines that go from the sun across the moon to the earth. Small shadow. The problem with this is, wouldn't this imply that the light is not parallel? If it's converging like that, that means it would eventually intersect. So let's get this straight. When science wants you to believe one thing, they'll show you intersecting light rays, but when they want you to believe something else they teach, they're only going to show you straight rays, like in this one. In the experiment that Eratosthenes did, the light had to be straight for it to work. If it wasn't straight, sundials wouldn't work.
I made this simulation to discuss this parallel light versus not parallel light problem. This is a scale model of the solar system. Because of elliptical orbits, the distance between Sun, Earth, and Moon do vary, and I used values that should be current on August 21st, 2017. At that date, the Earth should be about 94 million miles from the Sun, and the Moon, right here, should be about 228,000 miles from the Earth. This is the Sun, once again about 94 million miles from the Earth. There are lines coming from the top and bottom of the Sun, and they just go out to the Moon and barely touch it and go beyond to show where the shadow falls. If we head over to the Moon, just notice right here how close to parallel these lines look at this point. They're so close to parallel that in some situations you could call them parallel. After ages of scrolling, we're finally getting close to the Moon. You can see those lines coming from the Sun just touching the Moon and forming the umbra and penumbra. Now, once again, these shadow lines are almost parallel, but to be precise, the angle between them is about 0.53 degrees. 0.53 degrees has little practical meaning on the surface of the Earth. Sundials still work. Eratosthenes' experiment still works just fine. But when you're talking about this moon shadow, the 0.53 degrees becomes meaningful. It had over 220,000 miles to become meaningful. Over those hundreds of thousands of miles, this shadow has narrowed considerably due to those 0.53 degrees. If you measure it, that distance is actually pretty close to 100 miles. I'm not sure how much rounding has happened here, but pretty close to 100 miles. That's pretty accurate. So what we're saying here is that sunlight is both angled and parallel at the same time, depending on how precise you have to be. If you only need a rough number, then parallel is good enough. But if you are covering astronomical distances, then a tiny difference matters. Okay, let's watch this animation. It demonstrates the west to east thing, and I'll just go ahead and do it even though it's been done. To a person standing on this portion of the Earth, right under this line, the Earth is this little ball here, this would be the eastern sky, and this would be the western sky. This would be the azimuth, and these would be points between. The moon is right here. To this observer standing under this line, the moon is low in the eastern sky. As I move the animation, the moon heads higher into the sky and starts to go west. We'll zoom in a little here. The moon continues to head westward in this observer's sky dome. In spite of it moving west, notice that the shadow of it just barely starts to hit the west end of the planet now. The shadow does outrun those lines, heads eastward, and then the eclipse is over. We'll do a zoomed in version now. For reference again, this blue line points to the moon, or green, or whatever it is. And this is the eastward direction, and this is the westward direction. Again, the moon heading higher and westward. Its shadow has just barely hit the west end of the planet. See that umbra outracing our observer. Well, here's the conclusion. The heliocentric model does not have a problem with the eclipse. Not west to east shadow direction, not shadow size, not the S-curved path, though we didn't talk about it. Not anything. It works perfectly. Heck, it predicted the thing. As Jaron says, and I paraphrase, they've had 500 years to work out the kinks. Why shouldn't it work? That doesn't mean it's true. Well, we'll differ there, Jaron. This is just one more reason among many why, in fact, the heliocentric globe model is a representation of reality. Would to God we could lay to rest these objections in an overflowing graveyard of broken flat earth ideas. But as we all know, or if you don't yet know, you could find out if you spent the time. As we all know, among the flat earth community at large, broken flat earth ideas never really die. They come back like zombies even though there is no new life in them, searching for brains to eat. Don't serve them yours. And enjoy the eclipse.